Before jumping into, let me take the opportunity of introducing me and myself. I am Sanjay Kodukula, a rambler, artist, and a professional engineer. Today, my talk is going to be a mix of biology of human body with technology to bring up something good for the people. For the next 280 to 300 seconds, I'm going to talk about pure-tone audiometry. Table of contents. Introduction, ear, related terminologies, ATH curve, pure-tone audiometry, method of the experiment, results uptime. So, you must be seeing the slide why. What made me choose this? Let me tell you a story. The story is about connecting a sequence. A good day, like every other day, I walked into a bus and saw people around, very busy with their own drudgery. Saw them plugging in earpods and turning full volume, which arises a question in my mind, whether our ear can really bear this intensity. I meant the high intensity. The question has made me to come up with a project which I call it a software to measure the intensity of hearing and an advanced technique for the measurement. So, what is an audiometer? Is it a machine used for hearing loss? What is its functions? Classification? Current trend? An audiometer is a machine used for evaluating hearing loss. Audiometers are standard equipment at ENT clinics and in audiology centers. They usually consist of an embedded hardware unit connected to a pair of headphones and a test subject feedback button, sometimes controlled by a standard PCs. Such systems can also be used with bone vibrators to test conductive hearing mechanisms. Audiometer requirements and the test procedures are specified in IEC 60645 and the ISO 8253, which are the standards. An alternative to hardware audiometers are software audiometers, which are available in many different configurations. Let me talk about the internal functioning of the hearing. Sound waves travel through the outer ear, are modulated by the middle ear, and are transmitted to the vestibular cochlear nerve in the inner ear. This nerve transmits information to the temporal lobe of the brain, where it is registered as sound. Sound that travels through the outer ear impacts on the tympanic membrane, which is the eardrum, and causes it to vibrate. The three ocelli transmit this sound to a second window, which is the oval window, which protects the fluid-filled inner ear. In detail, the pinna of the outer ear helps to focus a sound, which impacts on the tympanic membrane. The malleus rests on the membrane and receives the vibration. This vibration is transmitted along the incus and stapes to the oval window. Two small muscles, the tensor tympani and the stapedius, also helps modulate noise. The tensor tympani dampens noise and the stapedius decreases the receptivity to high frequency noise. Vibration of the oval window causes vibration of the endolimb within the ventricles and cochlea. Related terminologies we use in the paper: frequency, pitch, sound intensity, sound pressure, speed of the sound, wave number, and amplitude. The graph shown in the figure is the ideal ATH curve, and the method we use is the pure-tone audiometry. We take a particular signal with a particular amplitude A and we go on reducing the amplitude with a particular factor till the person hears the last beep. So for different frequencies we do the same process and form the ATH curve. Based on the ATH curve, comparing with the ideal one, we describe the loss of hearing. Our objective through this project is to build an accurate machine, software machine, so that we can reduce the hardware cost, which is really helpful for the patients. That's my project, narrated by me, Sanjay. Thank you.